Pathfinder tone arm was made because of the XtraX.
Yes, yeah, absolutely. I'm not saying the Mystic doesn't work better in a Pathfinder. The Mystic works much better in a reference tone arm. In fact, every single product that we do, even you look at, for example, a Phono 1 that most people will associate with either a DG or an MG. It was actually developed when we were doing all the listening tests with our RG1 reference tone arm, reference motor drive, etc. Because if it can't work at that level, then we're not doing our job right. Obviously, it can't have the same resolution, it can't have the same dynamic range, it can't have the same impact that you get, for example, from a Calon. But it was developed with the best cables we had, with the best mains cable, best source, everything, in order to identify for us to know what is the limit of this product. Then we know how far we can improve the design. So if you have a next generation, you think, okay, the weakest part is this part on the circuit. Like when we went from Phono 1 to Mark II, when we went from the Mark II to L, the L-shaped PCB that we've done, it was mainly at that point in time that the grounding was compromised. So by that way, we managed to get the grounding and also the two tracks going left and right channels. We managed to get it more similar to each other. So the lengths of the tracks, the capacitance between the tracks and so on and so was more similar between one channel and the other channel.
So
the circuit is exactly the same. There's no change in componentry or the circuit as such. Most of it was actually the use of the real estate. Where do you put the components and how do you track in between and so on. And getting the power from the transformer, the AC from the transformer into the rectification circuit, having a lower impedance ground, having that kind of thing, you know. But ultimately, we don't test that with the lowest product we make. We test it with the highest product we make. Because that opens up the window so you can see everything that is good about the product as well as everything that is not good about the product. So therefore, you have a better chance of getting those trickier parts of the design, tidy it up, hone it so that overall doesn't have a very big weak link in it.
When you develop something, is it top-down, I mean trickle-down method?
90% of the time is top-down. Because especially if it is mechanical. I mean, even electronic parts that I work with, I don't have a feel for electronic components. I don't look at a circuit as, oh, there's a transistor, there's a capacitor, resistor. For me, a transistor is like a valve. You know, this is like an inertia. This is like a stiffness. This is mass. This, you know, you're looking at it more mechanically. So if, for example, I see, okay, this part of the circuit, you have too much mass on this side than this side. This needs to go down, that needs to come up. So you change the values, for example. Or you have too much inertia, you have too much damping or non-linearity and things. You know, I look at it more mechanically. So if it is a mechanical entity, I am very comfortable working top-down. When it's electronic, I rather work either somewhere in the middle and go up and down, or start at the basics just to see, okay, is the idea going in the right direction? You know, firm believer of every journey starts with a single step. Firm believer. But I'm also a firm believer of that step needs to be in the right direction. Otherwise, you were going in the wrong direction. You don't get to your destination. You know, so sometimes it works top down. Sometimes it works bottom up because you're trying to verify that the ideas behind something, the principles behind something, they hold. They're actually doing their job. Then you think, okay, I'm comfortable with that. I can now expand it to this level. And vice versa when you go down. most of the time, to be honest, when you down engineer or you up engineer, you don't end up with the same thing but bigger.
All right.
Because once you down engineer, once we were going to the DG, I couldn't make a cheaper SG toner. Maybe I can do today. But at that time, I'm thinking, okay, I can't. What do I compromise on? Everything I compromise is going to have a too big an impact on its performance.
Yeah.
So let's start fresh.
Yeah.
I know what I want to achieve. I know what this tone arm is supposed to do with supporting the cartridge and how it has to accommodate the record, for example. I know what it is its job.
Yeah.
But there are many ways of achieving the same end result, but at different resolution level.
Yeah. You brought all the good aspects of various cartridges into XtraX. You know, what kind of aspects?
No, for example, if I'm doing design on the Calon, I don't go and look at several other high quality phono stages because as a designer, I get too easily directed in a certain direction. So if I look at somebody else's product before I've thought about how to design this, I would be going in that direction. For me, it will take long time to come back. So I never open up another. I mean, I use a lot of people's electronics. I have never ever opened any of them. And the reason for that is so that if I am going to look at it, I'm looking at it from my angle. Afterwards, if I compare something and I'm too far different, then I may want to know why. But before that, I leave it. So with the cartridges, it wasn't so much that I wanted to pick this element from this cartridge, because I don't know why that cartridge has got this quality. All I know is that I can hear it. You know. So when the XtraX was being done, before that we had already done the Mystic. And on the Mystic, I knew where the compromises were. And the Mystic was based on a generator and a cantilever and a diamond assembly that has been designed and made by the companies who supply many manufacturers. But I knew how to get a better result out of it, purely on a mechanical basis. How do I support this engine? You know, so imagine like BMW, Mercedes, Jaguar, they all use the same engine blocks from the same manufacturer. They all use the same pistons and things, but they just specify slightly different strokes, different sizes, different shapes. So they tailor those building blocks to suit their philosophy of car design. So imagine the same thing applied on our cartridge. When the Mystic slowly became my only cartridge to listen to, because its deficiencies were not enough to make me go through the hell of taking this off, putting another one on, setting it all up, making sure, you know, it takes a long time before you're 100% happy with how the VTA is working, how the azimuth is adjusted, how the anti-skate is, tracking weight, etc., etc. So I was thinking, I know where the weaknesses are in the Mystic. This is where you're starting from the middle going up. Not from the bottom up, but from the middle going up. I thought, okay, let's apply the same technique as we applied on something like the Sabre. So the body design, how the shape is, where the masses are on the body, what is the mass of the body, etc. And then the position of the 4 screws that actually hold the generator in there. Because what it does effectively is allows the generator is not very heavy. From memory, if I'm not mistaken, is about 3 grams or 3.5 grams. It's quite light. But the whole unit is about 11 grams. But the generator part doesn't see 11 grams. The generator part, the cantilever that's being driven, sees the low mass of the engine. The body of the cartridge becomes part of your head shell. So it's almost like you've stiffened and made your head shell slightly heavier.
Okay.
So increasing your effective mass, which that cartridge actually likes to see, you know. So that was what was happening with the XtraX. And obviously, again, going back to what we were talking about, the tone arm, when you have a higher impact on the diamond, then the diamond assembly needs to be stiffer.
Right.
So that's why it's a newt diamond made on the length of the crystal on the diamond shank. So when they're grinding, machining it to shape, the crystals actually go in that direction. And then how it's bonded to the cantilever and the telescopic part at the back of the cantilever to deal with slightly more impact that you have on the diamond. And but yet keep the frequency response flat. It's not doing the peaks after 1K or 2K or something, you know.
Okay.
So that was the idea behind the XtraX.
Okay.